talk. Again, we hear from Christian Autermann, Interoperable Management and Provision of Metrological Data in Ocean Sciences.
This one? Down there. Yeah, it was just to check if...
Yeah, it's the right one. So, no, that's the wrong one. Because I'm doing PowerPoint karaoke in a kind of way today. This is a presentation of my colleague or my manager, Simon Jirka. Where is it? This one. Interoperable management and provision of meteorological data in ocean science. That's not a typo, it's about metrological data, not meteorological data. So the science of measure. And for us, quality, well, we view quality a little bit different in contrast to the previous talks, because for us, all data is good as long as it states how good it is, or what the quality of the data is. And that's basically the main thing we want to develop in Minke. Minke is a community founding project, so it's not about building infrastructures or building software. Of course, it's also a little bit part of that, but it's mainly about bringing together the metrology community and the oceanographic community and get them talking and find common values and common vocabulary to communicate with each other and to bring forward the oceanographic measurement process. Our part here is more about the description of the quality information of sensors and the measured data, just to understand how reliable is the data that we have. What is the bias? What is the confidence interval, and so on. All this stuff has to be encoded and in the best way, in a machine-readable way. Because we need that to understand what we can do with this data, because the end goal in Minke is to have a kind of data fusion between high precision, really costly networks of observational data and really maybe community-driven, low-cost sensors that are deployed by the citizen scientists. Examples for data that we try to collect and try to encode and try to find and to get a common sense on what it really is, for example, information about the calibration process, the quality and precision of the actual sensing devices, what process really was taken to measure things, because you can measure different phenomena different ways, and what processing was done on the data in the end. So was there a quality assurance process? Did we filter out outlier and so on? All the stuff should be there as metadata or as data. Our personal challenge was the interoperability part, because that is our topic. How can we provide this metadata to facilitate the processing and the machine-readable processing of this quality information, that maybe we can build systems that automatically can fuse data from local sensors and high-quality networks, and that we ensure that this minimum of information that we need, that this is required. And then our task was to develop guidelines, or is to develop guidelines, best practices, and so on. And of course, first we investigated what standards are there. We're coming from the sensor web community, so for us this choice was kind of obvious. We are using the ISO 19115 standards for the metadata about the data sets. We're using the sensor model language in the newest version, SensorML 3.0. We see here, this is coming from the Connected Systems API or Connected Systems WIG we talked before. We are using this also for the sensors and the data acquisition processes. The sensors, the OGC Connected Systems API also has interfaces for defining processes and the actual sensors. For observation data, we are planning to use OMS, which is the successor to observation and measurements. Now it's called observation, measurements, and samples. And consider also there to use the JSON encoding. but that's not there yet. We have a new standard with that is OMS, but we have no official JSON encoding yet, but we are using our temporary scheme we have in connected systems. For accessing the data, we're also using the Connected Systems API because, as stated earlier, the Internet of Things API lacks a little bit the capability to have dedicated, detailed sensor descriptions. That's why we are building in Minke our Connected Systems API based on PyGeo API, and it's kind of a testing balloon to test if what we are doing in this SWIG is really applicable to real-life problems and to real-life data. And one big topic will be the semantic interoperability between these different quality types or quality gauges. I don't know how to call that. We have a dedicated working group that develops a vocabulary for that, but there's a little bit of miscommunication because their end product will be a PDF document, and that's just not enough for us. So we will probably also work on creating a really dedicated RDF-based vocabulary and probably go to BODC Enoc to get that integrated there. Our other task was the sharing of this quality information, and we didn't stop at the Connected Systems API, but we want to somehow get that into EOSC, just that others can find the metadata about the sensors, about the calibration workflows, can discover data sets based on their quality and so on. The main problem was we contacted EOSC and asked, hey, how can we integrate our data into your system, into your infrastructure, and never got an answer. So we found our own way, and this is our recommended workflow for now in Minke, because we found out that there are public repositories like Zenodo, like Sinoe, that get harvested by EOSC. So we skipped the communication part with the EOSC, and our internal publications workflow is that the sensor is calibrated. We encode this calibration information in SensorML, publish it in our Minke data management platform, which is a Connected Systems API, export this as a SensorML file, and publish it in Sinoe or Zenodo, which is kind of meh, but of course, we would have liked that the EOS portal can directly link to the Connected Systems API, but this is our approach. Our Minke data management platform, as said, we are building currently a database for storing data received by the Minke partners, which is another problem because we didn't receive any data yet. But it's an OGC Connected Systems API based on PyGeo API, our implementation. We hosted in our AWS cloud. We want to host their metadata and the actual sensor data or calibration data sets. As said, it's a modern lightweight REST interface. And yeah, it's a way to have a test balloon for this OGC Connected Systems API and have this publication workflow in one place. Currently, we're working on the development of the implementation of the Connected Systems API. At the same time, we are working in the standards group, fixing bugs, finding problems, and clearing them up. And as said, we're having problems finding data for our test balloon. So Minke also has TNAs, so you can send in your sensors, they get calibrated by some lab, and you get them back with the calibration sheet and so on. And as nobody wanted to give us data, we are just applied inside the project ourselves. And now we, I think in the beginning of June, we can calibrate some sensors in Brest and have finally calibration sheets and calibration measurement series and so on that we can use to test it all out. So in summary, it's an interoperable provision of quality-related sensor data. So not that much to assure the data is really of high quality, but just to state what quality the data is. And we're using the SensorML standard and the OGC API connected systems for that. And it's also a way to publish these quality information into the EOSC. Thank you. Any questions? Yeah.
Thanks again, Christian, for the presentation. A while ago in the Every Fair project, we were looking for a framework to be able to map between different flagging schemes that the different research infrastructures...
That's a problem. Oceanographers thinking in terms of flags in data quality, but that's just not enough for us. We want to have really calibration curves of sensors. We want to know in really hard data, not good, bad, but what is the confidence interval of this value exactly. So we're not thinking in flags.
Okay, so we were looking at flags at that period. But I think the calibration is something that is very much wanted for a long time in the sensor community. So we will be looking forward to this work. And how soon is this going to be out?
The vocabulary.
We can help with the vocabulary.
Well, the project is running now since, I think, 2 years. We have still 2 years in the ongoing. Our deliverables are basically done, so we have the best practices. What's missing is the vocabulary, and yeah, as I said, it's mainly a community building research project. So the people started talking, and now they understand each other. Now I have to understand those both, because in the beginning, those didn't understand each other, and I was between these chairs because I don't understand either, and now they understand each other. But now I have to check that.
Okay, so you need the common language now.
Yeah, the common language. Yeah.
Yeah, if I may comment, because tomorrow I'm presenting IQUAD group work, and IQUAD has gathered literature information about the manufacturer, let's say, accuracy, and they use that to add uncertainty to the data in the historical collections. So what I see is that this application is useful for the new data that are coming. So this is the type, we call that type B of uncertainty that you can gather from this kind of work, which is very important and relevant when we try to integrate data from different instruments, as you say, and we have also the issue of citizen science with lower. So when we combine the data, we need to know which uncertainties to assign. So when we do application, we could weight the different observation regarding, taking into consideration the uncertainty. So it is very relevant. Other questions?
Just one question regarding metrology about metadata. One information that usually is not present is the code page. And this is something...
So the what?
Code page. It should be today UTF-8, but if you use JSON and other standards, especially if you use some weird letters, as is my case, so it can be big problem. So just I want to stress this kind of problem, because you never, if you don't have a proper header from JSON, for example, you cannot know.
Well, JSON is per definition UTF-8, so that's not a problem.
Yes, I understand, but you still can find the wrong code.
I think that's nothing a metrologist would think about the code page of the data, so it's not relevant for them. It's more like we have this 30,000 equipment, and we check that your temperature sensor has a deviation of 0.05 degrees, and that's what they are doing.
Okay.
So it's more about that quality of the measuring process, not of the data itself, or the data formats or encodings.